All right, Owls, this is going to be your first flip notes in the space unit, our final unit. And when you think of space, you think of planets and comets and meteors, black holes, constellations. But this unit will start off with talking about things that you see in your everyday lives that we experience because of objects in our solar system. So these are going to be five different predictable patterns. But before we get to those five, we're going to go over some basics first. First of all, we're going to define what a predictable pattern is. You're going to naively and jokingly want to answer this question with a pattern that's predictable. However, if you answer it that way, you're wrong. You have to say it the scientific way, which is a cycle of events that occur that we are able to time throughout the day, month, or year, and or could be years. Cycle is the same thing as a pattern, but it's a scientific word. So this is the definition I'll be looking for when you encounter this question in upcoming minors and majors. There are three objects in our solar system that will control the five different predictable patterns that we experience. Some happen more often than others, but those three objects would be the sun, moon, and earth. Now keep in mind, moon right there is in all caps, but it's not a proper noun. We call our moon the moon because we only have one, but that is not a common thing when other planets can have up to 60 plus moons. There are two factors that allow these objects to control the patterns that we experience, and these are words that you'll find often in social studies class, but it is based on the relative motion and the relative position, meaning how something's moving and where something is located of the sun, moon, and earth. So where these things or objects are located and how they're moving will make these patterns happen the way they are. Now this is something that's not in your note sheet. However, it's a big deal. If I were you, this is the one thing that is often misinterpreted and leads to errors in this unit because you don't understand the difference between these two words. Rotation is simply one thing spinning. If I just ask you to spin and spin and spin, you're rotating. However, revolution is one thing going around something else. Now, often in space, things will rotate and revolve, like we rotate and revolve around the sun. But revolution takes two things, rotation only takes one thing. And we say these two words because they come up often in these different patterns that we experience. The first pattern we're going to talk about is day and night. I think this is the simplest of all the patterns. You're going to write day and night in the pattern box. Then you're going to write the causes and facts, and then you're going to draw a picture of the illustration I will provide for you. There's one thing that causes day and night, and it's the rotation of Earth on its axis. And if you did not know, we're tilted at an angle. If you ever see a globe, you'll notice that the Earth is tilted. That's because we're tilted at a 23.5-degree angle. But this is the only reason why we have day and night, is because we are constantly rotating every single day. There's a misconception that the sun rises and sets. That is not true. It's just that the Earth is spinning. Earth makes one complete spin on its axis in 24 hours. It's about 24 hours. It's not exactly 24 hours, but that's why we made 24 hours a day. And at any one time, about half the Earth is in sunlight and the other half is in darkness. This is obviously an estimation. It is not perfect half and half. Here's an illustration that shows that, obviously not drawn to scale. The sun would be way larger than it is, but the side that's facing the sun is experiencing day, and the side that's not facing the sun would be experiencing nighttime. Now, the next pattern, I believe, is the most complicated one, is seasons. This is caused by several different things. It's first caused by the revolution of Earth around the sun on its tilted axis. It takes the Earth 365 days, actually like 364 and a quarter. This is where leap year comes in, to get around the sun. In that process, we experience 4 seasons here in North Carolina. Some places experience like 2 seasons. It depends on where you're located. Now with this, we have daily rotation of Earth, which causes the day length to change in directness, intensity of the sunlight. We're experiencing that right now. You'll realize when you wake up, it's light time. And when you go to bed, it's still probably around light time. But in the winter time, you wake up and it's dark when you go to school. And when you go to bed, it's dark. It's because the directness and intensity of the sun is angled differently during different points of the year. And the tilt of the axis of the Earth causes the seasons in the northern and southern hemispheres to be reversed. If you do not know what that means, it means when in North Carolina, when we're experiencing winter in December, in Australia, they are experiencing summer because they're in the opposite hemisphere as us. Here's a picture that shows how Earth goes around the sun. Obviously, when you watch a study by students from Harvard graduating, they asked about why we have different seasons, and they most of the time said we get further away from the sun, which is not technically true. It's just that we're angled differently. So even Harvard students will screw this up. The next one is moon phases. You should have learned about these in like 3rd grade, but we have to revisit these. Moon phases, our moon revolves around Earth, and they both revolve around the sun together. So they're both revolving. And the second one, the moon appears in a series of phases in different shapes. It does not change shape. This is the thing I see a lot wrong with students. They think the moon actually changes shape. It just appears that way because it's based on shadows from the sun onto the Earth, on the moon. And this is just a cool fact. The rotational period of the moon is the same as its period of revolution around the Earth, which means we always see the same side of the moon from Earth. This is where the whole idea of the dark side of the moon came from, because we never get to see the back of the moon from Earth. We always get to see the same side. Here's a picture of all the different moon phases. I actually last year saw these on the end of grade test that they actually wanted to know if you knew what the phases were. We'll talk more about that in class. The fourth thing is tides. This is ocean tides. And this is caused by the gravitational pull of the moon and sun. So there's 2 different gravitational pulls and the Earth's rotation. Because we're spinning every day, this causes the tides to work in a pattern that we can predict in a cycle. If you ever go down to the ocean, they'll tell you when high tide and low tide is happening because it's a predictable pattern. The gravitational forces can be in alignment with each other or in opposition with each other, and depending on which one they are, if they're in alignment, that's high tide. If they're in opposition, that's low tide. And then typically tides occur every 24 hours, and you usually get 2 low tides and 2 high. So if you can use your math skills, that means tides take about 6 hours to rise and fall. And you can see in my illustration where the moon is and how we're rotating, that water will actually balloon out, causing high tide, and then where the water is not getting pulled out would cause low tide, which means the water's coming off the coast. And we'll watch more videos about that in class. And the last one is eclipses. I think this is the easiest one. But this is an alignment of the sun, moon, and Earth, and they can produce shadows on the Earth or the moon, which that should not say Earth, that should say sun, which is known as an eclipse. So it's not Earth, it's sun. And then there's 2 types, lunar and solar, and the name of them lets you know which one it is. If the moon is shadowed, it's a lunar eclipse because luna means moon. And if the sun is shadow, it's a solar eclipse, or sola meaning sun. And here's a picture of each. It's a phase thing. These don't happen all the time, but they're predictable when they do happen. So because they're predictable and it's a cycle, they will know in the next 15 years when the next one will occur from where you're standing or what you're standing around. All right, have these notes completed. We'll check them and discuss them in class tomorrow.